Company wants to chain multiple foundation model calls where the output of one model feeds into another with conditional branching based on intermediate results. Which service is most appropriate for this orchestration? A, Amazon Event Bridge pipes for event-driven chaining. B, Amazon Bedrock flows for visual workflow design. C, AWS Lambda with custom chaining logic. D, AWS Step Functions for explicit state management and conditional logic. The correct answer is D. This question is about orchestration with decision logic. Look for the clues: multiple steps, conditional branching, state management. AWS Step Functions is purpose-built for this. It gives you choice states, retries, and error handling, execution history, visual workflows. This is exactly what complex foundation model chaining requires. So D is the correct answer. Why are the other answers incorrect? A offers event bridge pipes. It's good for routing events, not conditional workflows. B suggests bedrock flows. Useful for simple prompt chains, but limited for complex orchestration. C is incorrect because it re-implements state, retries, and error handling manually. So custom Lambda logic does not work here. For multi-step GenAI workflows with decisions, use step functions. The correct answer is D. A company compliance team needs weekly reports on which users access which Bedrock models and knowledge bases. A company's compliance team needs weekly reports on which users access which Bedrock models and knowledge bases. Which combination of services provides this reporting capability? A, Amazon Detective for user behavioral analysis. B, AWS config rules monitoring Bedrock resource changes. C, Bedrock model invocation logs analyzed with CloudWatch logs insight. Or D, CloudTrail logs delivered to S3 and queried with Amazon Athena. The correct answer is D. This is a compliance auditing question. The team wants who accessed what, when, over a reporting period. On AWS API level, access auditing is handled by CloudTrail. When you deliver CloudTrail logs to S3 and query them with Athena, you can generate detailed scheduled compliance reports using SQL. That is the standard AWS pattern. So D is the correct answer. The other answers are incorrect because A, Amazon Detective, is designed for security investigation, not routine compliance reporting. B, AWS Config tracks configuration changes, not API access. C, invocation logs are helpful for debugging but lack AIM identity data. For user to service access reporting, CloudTrail plus Athena is the gold standard. The correct answer is D. The company's Bedrock application occasionally times out when calling large language models. They want to implement resilient error handling. Which pattern is most appropriate? Implement circuit breaker pattern with step functions that fails fast and returns fallback responses on repeated failures. B, increase lambda and API gateway timeouts to accommodate slow responses. C, add retry logic in the client application. Queue all requests through SQS for asynchronous processing. The correct answer is A. The question is about resilience, not just making timeouts go away. The key problem is Bedrock calls sometimes fail or take too long, and the application needs to handle that gracefully. When you see repeated failures, downstream service instability, and need to protect user experience, your exam brain should think circuit breaker. A circuit breaker does these three important things: stop sending traffic to a failing service, fails fast instead of waiting for timeouts, and returns a fallback response. AWS Step Functions is an excellent place to implement this because it can track failures across executions, branch logic when thresholds are exceeded, and automatically recover when the service stabilizes. That is exactly what option A describes, so A is the correct answer. Why are the other answers incorrect? B is incorrect because this makes users wait longer when things are broken. It does not improve resilience. C is incorrect because retries can overload an already struggling service and make outages worse. D is incorrect because the SQS queuing changes the app to asynchronous behavior, which is usually unacceptable for interactive GenAI use cases. For resilient GenAI apps, fail fast with a circuit breaker, not longer timeouts. The correct answer is A. A team is debugging why their Bedrock agents takes longer than expected to complete tasks. They need to understand time spent in each step. Which tool provides this breakdown? Here are your answer choices. Option A, Bedrock model invocation logging for individual call times. B, Lambda insights for function level performance. C, AWS X-Ray distributed tracing with subsegments for each component. And D, CloudWatch metrics for aggregate latency. The correct answer is C. This is a where is the time going question. The team does not just want averages. They want to see each step in order for a single request. That immediately rules out aggregate metrics. AWS X-Ray provides distributed tracing, which means one trace across API gateway, Lambda, Bedrock, tool calls, and back again. With X-ray subsegments, you can see which step is slow, whether cold starts matter, and whether the delay is model inference or tool execution. That is exactly what this question is asking for. So the correct answer is C. Why are the other answers incorrect? A is incorrect because model invocation logging shows model calls only, not the full request path. B, Lambda Insights is great for Lambda internals, but blind to everything else. And D is incorrect, CloudWatch metrics, because they aggregated data, so which cannot explain individual slow requests. For step-by-step latency analysis, use X-ray distributed tracing. The correct answer is C. Company needs to ensure their vector embeddings remain useful as their product catalog grows from 100,000 to 10 million items. Which consideration is most important for scalability? A, choose embedding dimensionality and index configuration that balances precision with storage and query performance at scale. Store embeddings in Amazon DynamoDB for automatic scaling. C, generate embeddings on demand at query time instead of pre-computing. D, use the highest dimensionality available for maximum semantic precision. The correct answer is A. This question is about vector search at scale. As your data grows, three things explode if you're not careful: storage size, query latency, and index efficiency. Embedding dimensionality affects all three. Higher dimensions mean more bytes per vector, more distance calculations, and slower searches. At small scale, that is manageable. At 10 million items, it becomes very expensive. The correct approach is to choose dimensionality intentionally and tune your index for scale. That is exactly what option A describes. So A is the correct answer. Other answers are incorrect because B, DynamoDB cannot perform vector similarity search. C, on-demand embedding generation adds latency and API bottlenecks at query time. D, more dimensions are not always better and severely hurt scalability. At scale, embeddings are a trade-off, not a max out setting. The correct answer is A. The company wants to expose their Bedrock-powered assistant as both a REST API and a WebSocket endpoint for real-time streaming. Which API gateway configuration supports both patterns? Option A, use single REST API with streaming enabled for all endpoints. B, use HTTP API with Lambda response streaming for both patterns. C, deploy application load balancer with path-based routing. D, create two separate API gateway APIs, REST for synchronous and WebSocket for streaming. The correct answer is D. This question is testing whether you understand API communication patterns. REST is request response, stateless, simple. WebSocket is persistent, bidirectional, and ideal for streaming tokens. API Gateway treats these as different API types for a reason. When you need both patterns, the correct design is to deploy both. REST API for synchronous calls, WebSocket API for real-time streaming. They can share the same backend logic. That is exactly what option D says. So D is the correct answer. Why are the other answers incorrect? A offers REST with streaming. REST does not support true server push streaming. B, HTTP API streaming still requests response, not persistent connections. And C, ALB routing does not replace API gateway WebSocket features. REST and WebSocket solve different problems. Use both when needed. D is the correct answer. Company stores training data in S3 that feeds their fine-tuned model. They need to ensure data integrity and track who modified training data sets. Which controls are most appropriate? A, enable S3 object lock with compliance mode and configure AWS CloudTrail S3 data events. B, configure S3 event notifications to Lambda for change detection. C, Enable S3 server-side encryption with customer-managed KMS keys. D, use S3 cross-region replication for backup and versioning. The correct answer is A. This is a data governance and integrity question. The requirements are very clear. Prevent unauthorized modification, prove who accessed or attempted changes. S3 object lock in compliance mode gives you immutability. Even admins cannot alter the data. CloudTrail S3 data events give you who accessed the object, what operation they attempted, and when it happened. Together, these provide both prevention and auditability. That combination is exactly option A. So A is the correct answer. The other answers are wrong because event notifications detect changes after the fact. They do not prevent them. C, encryption prevents confidentiality, not integrity or audit trails. And D, replication copies changes, including bad ones. For ML training data, use immutability plus auditing. The correct answer is A. Company wants to understand the cost breakdown of their Bedrock usage across different applications and teams. Which approach provides the most granular cost attribution? Here are the answer choices. A, tag Bedrock resources and use cost allocation tags in Cost Explorer, combined with model invocation logs for per application analysis. B, calculate costs manually based on CloudWatch token metrics. C, create separate AWS accounts for each team. D, use AWS Cost Explorer with service level filters. The correct answer is A. This question is about granularity, not just total Bedrock spend, not even per service spend. The company wants to know which application, which team, and how much usage. That immediately tells you tags are involved. Cost allocation tags let you break down costs down by things like team, application, and environment. But there's an important nuance here. On-demand Bedrock usage is driven by API calls, not long-lived resources. That means tags alone are not enough. To get true per application attribution, you also need model invocation logs, which show which application made the call and how many tokens were used. When you combine cost allocation tags for billing visibility and invocation logs for per call attribution, you get the most detailed cost breakdown possible. That's exactly why option A is the correct answer. The other options are wrong because manual calculation from CloudWatch is error prone and hard to manage and does not align with AWS billing data. C, using separate AWS account gives isolation, but it creates massive operational overhead and is unnecessary for cost attribution. D, service level Cost Explorer filters only shows total Bedrock spend, not who or what caused it. For Bedrock cost attribution, combine tags for billing and logs for usage. The correct answer is A. The team suspects their RAG system is over-retrieving documents, sending more context than necessary to the foundation model. Which metric should they analyze? Option A, foundation model output quality scores only. Option B, input token counts per request and context relevant scores from RAG evaluations. C, response latency and token generation time. D, OpenSearch query latency and shard distribution. Correct answer is B. This question is about diagnosing over-retrieval. Over-retrieval means too many documents, too many chunks, too many input tokens. So the first metric you should look at is input token count. But token count alone is not enough. You also need to know whether the retrieved content is actually useful. That is where context relevance scores from RAG evaluations come in. The classic over-retrieval pattern is high input token counts and low relevance scores. That tells you the system is retrieving a lot of content that does not help answer the question. So the correct answer must include both metrics. That's exactly what option B gives you. So B is the correct answer. The other answer options are incorrect because A offers output quality scores only. These measure outcomes, not retrieval behavior. C, latency shows symptoms, not the cause. And D is incorrect because OpenSearch infrastructure metrics optimize performance, not retrieval relevance. To detect over-retrieval, measure how much context and how relevant it is. The correct answer is B. The company wants to build a search system that can find similar products by color and style from user uploaded photos. Which Bedrock capability supports this use case? Here are answer options. A, Amazon TextTrack for extracting product information from images. B, Amazon Titan multimodal embeddings that directly encode images into the same space as text. C, Amazon recognition for object and scene detection. D, Amazon Titan text embeddings with image descriptions generated by Claude. The correct answer is B. This is a visual similarity search question. The requirement is find products that look similar based on color and style from images. That tells you immediately this is an embedding problem, not a labeling problem. Amazon Titan multimodal embedding encode images and text into the same vector space. That allows you to compare image to image or image to text using vector similarity. This is the most direct and accurate way to do visual search. So B is the correct answer. Why are the other answers incorrect? TextTrack extracts text from documents, not visual features. Recognition returns label, not similarity searchable embeddings. And D, text embeddings with descriptions convert images to text first and loses visual detail. For visual similarity search, embed images directly, not descriptions. The correct answer is B. Company needs to run their Bedrock-powered application closer to users in edge locations for lower latency. Which AWS service combination supports this architecture? A, deploy Bedrock endpoints in all available regions using cross-region inference. B, use AWS wavelength zones for 5G edge access with backend services calling Bedrock in the parent region. C, deploy Lambda at edge functions that call Bedrock from CloudFront edge locations. D, use Amazon Outposts to run Bedrock locally. The correct answer is B. This is an edge computing question. The requirement is run closer to users, especially mobile users, for ultra low latency. AWS Wavelength is specifically designed for this. With Wavelength, application logic runs at the 5G edge. Bedrock runs in the parent region. Traffic stays on the AWS network. This gives you fast response to user without trying to run models at the edge. So the correct answer is B. The other answers are incorrect because option A, cross-region inference, improved resiliency, not edge proximity. C, Lambda at edge has strict timeouts and networking limitations. And D, Bedrock does not run on outposts. For GenAI at the 5G edge, use Wavelength plus regional Bedrock. The correct answer is B. Companies' GenAI application must comply with industry regulations requiring encryption of all data at rest and in transit. Which configuration ensures comprehensive encryption? A, configure S3 encryption with customer-managed KMS keys, use VPC endpoints for private network access, and enable TLS for all API communications. B, use AWS Certificate Manager for SSL certificates on API Gateway. C, enable CloudTrail encryption for audit logs. D, enable S3 default encryption and rely on TLS for Bedrock API calls. The correct answer is A. This is a comprehensive encryption questions. The requirements are encryption at rest, encryption in transit, and regulatory compliance. That means customer-controlled keys, private network paths, and TLS everywhere. Option A is the only choice that covers all three. KMS customer-managed keys for storage, VPC endpoints to keep traffic off the public internet, and TLS for API communications. This is what regulators expect. The other answers are incorrect because B offers ACM only, and that covers external TLS, but not storage or internal traffic. C offers CloudTrail encryption, which protects audit logs, not application data. And D uses AWS managed keys and does not meet strict compliance needs. For regulated GenAI workloads, encrypt everywhere and own the keys. The correct answer is A. The company runs batch embedding jobs that currently take 48 hours to complete. They want to reduce this to 12 hours without changing the model. Which approach most effectively increase throughput? Here are the answer choices. A, use Bedrock batch inference with increased provisioned model units. B, enable cross-region inference to use capacity in multiple regions. C, reduce chunk sizes to generate fewer embeddings. D, parallel requests from across multiple Lambda functions. The correct answer is A. This is a pure throughput question. The company's not worried about latency. They're not changing the model. They're running large offline batch jobs. That combination should immediately trigger one phrase in your mind: Bedrock batch inference. Batch inference is designed specifically for large offline workloads, predictable completion times, and guaranteed throughput. By using provisioned model units, you're reserving dedicated capacity for the duration of the job. If the job takes 48 hours today and you want it done in 12, you scale throughput by provisioning more model units. That gives you linear improvement without touching the model. That's what A describes, so A is the correct answer. Why are the other answers incorrect? B is incorrect because this is cross-region inference is for resiliency and quota aggregation in on-demand scenarios, not guaranteed batch throughput. C is incorrect because smaller chunks usually mean more embeddings, not fewer. This can actually increase total processing time. D is incorrect because lambda parallelism still hits bedrock on-demand quotas and does not guarantee throughput at scale. For large offline jobs, by throughput, not workaround. The correct answer is A. The team needs to benchmark their bedrock RAG application against competitors' published results using the same evaluation data sets. Which approach ensures fair comparison? Here are your answer choices. Option A, use CloudWatch metrics to compare operational performance. B, collect user satisfaction scores and compare averages. C, use custom evaluation scripts with the same metrics definition. D, run Bedrock evaluation model evaluations with standard benchmark data sets and LLM as a judge metrics for consistent, reproducible results. The correct answer is D. This question is all about fair benchmarking. The key phrase is using the same evaluation data sets. If competitors are publishing benchmark results, they're almost always using standard data sets, standardized metrics, and repeatable evaluation methods. Amazon Bedrock Model Evaluations gives you just that. It supports common benchmark data sets, standardized RAG metrics like correctness and faithfulness, LLM as judge scoring that is consistent across runs. That is what allows you to say, we ran the same test the same way, and here are our results. That makes the comparison credible. So D is the correct answer. Why are the other answers wrong? Option A offers CloudWatch metrics. These measure performance, not answer quality. Option B is incorrect because user satisfaction scores are highly subjective and impossible to compare across different user populations. C is incorrect because even the smallest differences in metric definitions break comparability with published benchmarks. For competitive benchmarking, use standard data sets and standard evaluations. The correct answer is D.